Hello, and welcome to TU Delft, at least virtually. My name is Mauricio Anishi, and I am one of the coordinators of the Computer Science Master's program that we offer here. And in this video, I'm going to explain to you how the program works. So let me start with the structure of the program. We offer three different tracks: data science and technology, software technology, and artificial intelligence technology. I'm going to explain the differences between those tracks very soon. And on top of those tracks, we offer what we call the special programs. And there you can dive into topics like cybersecurity, bioinformatics, and information architecture. Then, to get your master's diploma, you have to complete 120 Cs in the track that you pick. And these 120 Cs you need to spend in the categories I showed on the slide. So you have to pick a few common core courses, as we call. So each track offers core courses, and you have to select a few of them. You also will need to do a seminar or a literature study, and this takes up to 5 to 10 ECs. Then computer science courses in general, and we offer a bunch of them. You can also take free electives, as we call, and in those free electives, you are actually free to pick courses even from other faculties inside TU Delft. And finally, the master thesis project that takes 45 ECs. So if we think of the 2 years that you're gonna be in here with us, this is usually what it looks like for the student. So the first year is full of courses. So this is where you do your core courses, free electives, computer science courses, etc., etc. So basically courses. You go to the summer break, you come back to the second year. The first quarter of the second year is also usually courses, and then in the remaining 3 quarters is where you do your master thesis project. So basically that's what happens, right? First year, courses, courses, courses. Second year, your amazing research project that will end up in your master thesis. Yeah. Then another way to show this, and now maybe a little bit more focused on the thesis, which is to me one of the most exciting parts of the program. So how does this work in general? So we have the quarters here, and when you start in Q1, we ask you to do a study planning, as we call. So you're gonna select, the track, and of course the courses you're gonna take. And your selection of courses will basically indicate which research group you're gonna join later on to do your thesis. At the beginning, given the number of students we have, we suggest you to pick more than one research group. So you try to design your studies in a way that you fit more than one research group. And then the more the time passes, the more you now know what you want to do. And then you start to reduce your options up to the point that you have your favorite research group, and then you do your thesis. So at the beginning, you do some preliminary planning. Once you know a little bit more, you then submit a more official study planning to us, and we will take a look at it. We will give you some feedback. Then a little bit before summer, it is nice if you start to talk to the different research groups and find an advisor for your thesis project and agree on the project. You start your project in around the end of Q5, and then this is where you're gonna work very closely to the research group. And then you basically have a midterm review where we see how you're going with your master thesis. Then very near to the end of your studies, we give you the green light, meaning you can defend your thesis, and then finally you defend the thesis. You present your research, you get feedback from the committee members, and then you graduate and you get your diploma. So that's how it looks like from more of the master thesis perspective. So now let me dive into the 3 different tracks. So, and the first one I'm going to talk about is the software technology track. And well, we know that software has a major impact on our economy. A lot of the companies nowadays are software companies behind the scenes. They produce software and very important software that cannot fail. It should work, and that's how it delivers um, business value, right? And without software, those high-tech companies would not really work. So this track is basically focused on making you the best possible software engineer that you can be. If I put this into learning objectives, in this track you're going to learn how to design, develop, and implement software, algorithm, languages, and architectures. You're going to learn how to embed them within the information processing systems that might be around. You're going to understand the structure and the properties of sequential, parallel, and distributed systems, because after all, software systems need to scale. And you're going to learn how to design complex algorithms to solve challenging problems. And just to give you a grasp of the common core courses of this track, you got to pick at least five out of the 11 core courses that we offer here. So compiler construction, distributed algorithms, real-time systems, behavior change support systems, 3D computer graphics and animation, advanced algorithms, multimedia search and recommendation, security and cryptography, web science and engineering, machine learning 1, and software architecture. So you can see that the set of courses is very diverse, and this gives you a lot of freedom to explore and then to choose the area that you like the most. Each of the tracks also have 2 coordinators, and those are the people that you should talk whenever you have questions. And for the software technology track, we have Rafael Bidaha and Jan Reddermeyer as the coordinators. Then the next track, data science and technology. And the point of this track is that data is so pervasive in our society right now, and the idea is that we can leverage this data to improve the way we work. So as I have in the slides here, digital data have become the key to innovations in both social and scientific domains. And the cool thing is that data can be leveraged for so many different domains like energy, economy, health, climate, bioinformatics, etc., etc., etc. So the goal of this track is to basically teach you how to learn from this data and get insights from this data so that we can improve the way society works. If I put this into learning objectives, in this track you're going to learn how to engineer and develop systems capable of processing and interpreting massive datasets to extract information and to gain understanding. This is the list of common core courses for this track: cyber data analytics, data visualization, AI techniques, web science and engineering, multimedia search and recommendation, software architecture, distributed algorithms, distributed computer systems, and machine learning 1. The coordinators of this track are me, Mauricio Nishi, and Klaus Hildenbrandt, and you feel free to email us whenever you have questions about the track. And finally, the third track, artificial intelligence and technology. And as we know and we hear everywhere about it, AI is changing the way society works as well, right? Problems that we never thought we could solve, we now can solve by leveraging artificial intelligence techniques. And we see machine learning and deep learning and AI making disruptive changes in so many different domains, like self-driving cars, smart infrastructures, smart cities, health, education, etc., etc., etc. So basically the goal of this track is to teach you different AI techniques so that you can apply AI on whatever domain you feel like you want to work. In terms of learning objectives, in this track you're going to learn how to design and engineer AI software systems, which are software systems that combine data with intelligent algorithms embedded in a larger software ecosystem of the application domain. Those are the common core courses: artificial intelligence techniques, algorithms for intelligence decision making, conversational agents, deep learning, information retrieval, machine learning, multimedia search and recommendation, evolutionary algorithms, and software architecture. And the coordinators are Jan van Hemert and Christoph Loffy. So The three tracks, I just talked about them. Now let me talk about the special programs. And special programs are a program that you can add on top of your track. So you select a track, and if you feel like you want to complement your track with something else, you can go for the special program. And as I said, we offer three special programs right now. The cybersecurity program, and this program is a combination of the four TUs. So you're going to have lectures from professors from Eindhoven, from Wageningen, and etc. Twente. And the focus is cybersecurity, of course. We also offer the information architecture special program, and this one is in collaboration with the other faculty we have here at TU Delft, the Technology Policy and Management, the TPM faculty. And finally, the bioinformatics, because we have one of the best research groups in bioinformatics. And of course, if you pick this special program, or one of them, the special program is mentioned in your final diploma. We have coordinators also, and Christoph Loffy is the coordinator for the Information Architecture program, Thomas Abel is the coordinator for the Bioinformatics, and Stepan Picek is the coordinator for the Cybersecurity program. So I talked about the tracks, I talked about the special program. Let's now talk about the computer science courses, seminars, and etc. So just to quickly revisit, you have to pick common core courses, seminar courses, computer science courses, free electives, and the thesis. And computer science courses are the courses that our faculty offers for you on whatever computer science topic there is, and you're also free to pick. And we offer so many courses. This is actually, to me, one of also the big advantages of studying here at TU Delft. Okay? And just to give you an idea of how many courses we teach, I'm going to walk you through the next 4 quarters that we are going to offer right now. I just got this from our study guide. You can visit the site online and see all the courses, but this is the list of courses we offer in Q1. And you can see different types of things, right? Compiler construction, networking, ad hoc networks, medical visualization, advanced algorithms, system validation, etc., etc., etc. Also scientific writing, which is a very important course, given that you're going to write a master thesis at the end, and learning how to write in a scientific manner is also very important in the real world. Second quarter, you see performance analysis, building serious games, quantum communication and cryptography. Third quarter, also a huge list of courses, blockchain engineering, software verification, educational technologies, real-time systems, etc., etc., and fourth quarter. So you see that this list is really huge. And my suggestion to you is, once you join us, you then spend some time reading about those courses and trying to select the courses you're going to take. And maybe I didn't mention this, but of course you're free to change your mind. So if you plan something in Q1, and then you go to Q2 or Q3, and then you notice you start to like some topics more than others, you're always free to kind of change, the future courses you are going to take. So you're basically responsible for your own education. Specializations, so those are basically the research groups we have. And the idea is that you at some point will join one of those research groups to do your thesis. And as you can see, we offer we have so many different research groups: algorithms, computer graphics and visualization, cybersecurity, embedded software, iterative intelligence, multimedia computing, network architectures and services, distributed systems, pattern recognition and bioinformatics, software engineering, web information systems, and programming languages. So many different options, and what you need to do is to find out which one from those you like the most and you want to really specialize. How can you choose? Well, how can you get to know one of those groups? One of the best ways to do this is to follow the seminar that are offered by those groups. So seminars are basically courses where you read the state-of-the-art papers in that area. And those are offered by the faculty members of those groups. And this is an amazing opportunity for you to really dive into the topic and get to know an advisor. So you can pick a seminar course. Those seminar courses, they usually have 5 ECs, some of them maybe 10 ECs. Or if you don't want to take a seminar course, you can also choose to do a literature survey, which means you pick an advisor, and then you're going to write a literature survey in the topic of the advisor. A literature survey is basically a paper where you dive into 30, maybe 40, 50 research papers on a specific area, and you write about those. So this is also a very good way to know one specific topic, and then find, like a small next step that you feel it's needed in the area, and then that can be your master thesis. In here you can see some of the seminar courses we're offering right now, and you see that they are basically related to the research groups that we have. And of course, one interesting thing to notice is that a lot of them are offered in Q1, right, or Q5 for you, because then it's kind of the last quarter near you starting your thesis. Then finally, let me talk a little bit about admission requirements. But definitely the best way to know them all is to visit our website, because it always contains up-to-date information about admission. And in here, I'm going to just talk about the most common ones. Feel free to contact us or the email that I put below if you have more questions. But usually, if you have a Dutch computer science degree from another faculty in the country, you are admitted directly. If you have a bachelor's degree in applied mathematics or electrical engineering from one of the 4 Dutch technical universities, you're eligible. You might be eligible to our bridging program. So check the website and then see if you meet the criteria. If you have a Dutch HBO degree, you're not directly admitted to the program, but you also might be eligible for that by taking the bridging program as we call. So please also check the website. For international students, we have 2 procedures. So first, for European students, we have a rolling admission. So you basically submit your CV. We're going to see if your CV meets all the criteria. And if it meets all the criteria, we will just send you an email back with a positive confirmation. It usually takes us from around 6 weeks to reply to you. For non-European students, we do what we call ranked batch admission, which is you submit your CV and the entire application package. So please check in the website. And once we have your package, we put it in a batch, in a group of students, and then we rank those students according to our criteria, and then we select the top ones. So there's some sort of ranking going on there. All international students, they should submit their GREs, right? So the general test score. So please check our website for more information. How to get more information? Well, our web pages. So our website is very complete. So visit the computer science master's page that we have at tudelft.nl, and all the questions about how the program works. Basically everything that I said in this presentation is available there: admission, master thesis, etc., etc. If you're also curious to know what a master thesis looks like, you can go to our education repository, and all our master theses are there. This is actually a good tip for also when you're a student already and you're about to start your thesis. Just download some of the theses from the research group you're doing your thesis, and then take a look at them. And of course, talk to the lecturers. If you're here, you can talk to the lecturers. You can ask them questions. You can talk to former students in the year after you, so they can share lots of experiences. And if you have questions about the program, curriculum, or courses, the best is to send an email to info-eemcs@tudelft.nl. And the people behind this email know how to answer your question, or they know the right person to answer your question. So that was it. I hope you enjoyed, and I hope to see you soon here at TU Delft. Bye bye.